So good afternoon, everyone. Welcome to Deep Learning IIT Roper course. This is the week fifth. So basically, in this week fifth on the NPTEL portal, most of the lectures are based on all the lectures are based on the linear algebra. So like it will be very useful in the upcoming week lecture series. So we will go through the basics of those linear algebra today, and we'll see the questions based on that, whatever taught in the week five. So if the students can also see the recorded lecture that is uploaded in the Excel sheet at the NPTEL portal. But the students who is watching live can uh, ask the question in the chat box. So like we'll start the today's week fifth tutorial session that is based on linear algebra. So coming to the most important topic which was discussed in the week five was the eigenvalues and the eigenvectors. So the first we'll see how to calculate the eigenvalues. So we know that for calculating eigenvalue, what we do, uh, we just find a minus lambda I, we just equate it to 0, get the equation in terms of lambda, and we find the value of lambda, and those lambdas are our eigenvalue for matrix A. Okay, so we have this matrix A given here and we have to find the eigenvalue of this. Before that, we will just write the three important points. Just this is a note point. You can have it. Like if any row, like in any row or column, if all the non-diagonal elements are zero, then the non-zero element is one of the eigenvalue. If all the non-diagonal elements are zero, then diagonal element that is also non-zero element is an eigenvalue. Okay. And one more second point. If sum of all the rows या column is unique, then the sum is an eigenvalue. So these are the short tricks which you can apply to find the eigenvalue. If sum of all the rows या column is unique. The sum of all the column is same. Like if you take column 1, column 2, column 3, if you sum it, if it is same, then that sum is the eigenvalue. Okay. But in this question, it is not same. And we also know that trace of matrix A is the summation of all the uh, lambda I, sum of all the eigenvalues. So now we'll solve this question. Before that, I will add some empty page. So now we can see the note point 1. Here it is written that in any row or column, if all the non-diagonal elements are 0, then diagonal element is the eigenvalue. So here you can see in this row, in this column, that is column 1, all the non-diagonal elements are 0. So this is our one of the eigenvalue. So here lambda 1 is equal to, I will just write the matrix. 1 0 0 minus 1 5 6 5 6 5. So lambda 1 is equal to 1. And also we know, as you can see in the third point, trace of A is the sum of all the eigenvalues. So in this, there are three eigenvalue. So this will be equal to 5 plus 5 plus 1. What is trace of A? That is summation of all the diagonal element. That is equal to 11. But lambda 1 is given as 1. So lambda 2 plus lambda 3 is equal to 10. Okay. And also one more point you write, that the product of all the eigenvalues, that is equal to the determinant value. Okay. So now we'll calculate the determinant value of A, that is equal to 1 into 25 minus 31, and these two elements are 0, so that is equal to minus, actually this is minus 6 here, sorry. So this will be plus 31, that is equal to 61. Okay, so lambda 1 into lambda 2 into lambda 3 is equal to 61. Lambda 1 is 1, so lambda 2 into lambda 3 is equal to 61. Here we can substitute that uh, lambda 3 is equal to lambda 61 by lambda 2. Okay, this we will substitute in this above equation. This is our equation 1. Then substitute in equation 1. We will get lambda 2 plus 61 by lambda 2 is equal to 10. That will be lambda 2 square plus 61 into 61 is equal to 10 lambda, is imply that lambda 2 square minus 10 lambda plus 61 is equal to 0. So now we can find, using the quadratic equation formula, that is equal to 10 plus minus, this is b squared, 100 minus 4 into 61, that is 244 divided by 2a, that is equal to 2. So our other lambda is 10. This is minus 144, that is 12i. 10 plus minus 12i by 2. So our lambda 1 is equal to 1, lambda 2 is equal to 5 plus 6i, and lambda 3 is equal to 5 minus 6i. So these are our eigenvalue. Okay. And also you can find using the traditional method, that is just you do solve this characteristic equation of A, that is determinant of A minus lambda I is equal to 0. In this way also we can solve. So like this was little shortcut. So you can solve in this way also, that is alternative way. I will take new pen. So if you guys have any doubt, let me check whether this uh, tutorial is recorded or not, because after that we can upload, so that if any student misses this lecture, they can watch it later. So alternate way is that we'll just write the characteristic equation, that can be written as A minus lambda I, that is equal to 0. So here we'll get our A is this, so we will subtract with lambda I. So we will get here 1 minus lambda minus 1 5 0 0 5 minus lambda 6 minus 6 5 minus lambda is equal to 0, because lambda will be in the place of diagonal element, so everywhere we'll do minus lambda. Okay, and now We'll find the determinant and solve the equation for lambda. So we will get 1 minus lambda 5 minus lambda square plus 36, that is equal to 0. So we will get 1 minus lambda square minus 10 lambda plus 61 is equal to 0. So here you can get lambda is equal to 1, and we have already solved for this equation. So here we'll get lambda is equal to what we have solved, 5 plus minus 6i. So lambda 2 is equal to 5 plus 6i, or lambda 3 is equal to 5 minus 6i. So any doubt in this, like how to find the eigenvalue for any given matrix? If you have any doubt, then you can ask in the chat box. So now I guess we can move on to the next question, that is based on the eigenvector. So here in this question it is given, consider a matrix 3, 4, uh, that is the first row, second row is 1, 2, that hits a vector 3, comma 3, 3. Which of the following will happen? So a matrix is multiplied with 3, 3. What will happen here? Can you answer? You can answer in the chat box as I am solving. You can also try yourself. So what will be the answer? Like before that, I will go through some concept and you can try solving this. Like see, if any vector is given, that is x is equal to 1, 1, and if we multiply x with a, and if a is the eigenvector, then the vector will only get scaled. Okay, it will not change the direction. So in this case, vector will get scaled. So here, if x is multiplied with a and a is the eigenvector, so vector will get scaled here, and the direction will not change. So whenever a vector is multiplied with the eigenvector, then direction will not change. Only the vector will get scaled. Scale means either it will be elongated or compressed. So in this question, first we'll multiply. Let's suppose uh, this is our a and this is our x. So we'll find ax. Ax is equal to 9 plus 2, that is 21, and this is 3 plus 6, 9. Okay. So earlier our x vector was 3 comma 3. So this was our vector. Let's suppose 3, this is 3. Now we have multiplied with a and it became 9 comma 21. So this is 9 and let's suppose this is 21. So now the vector is changed in this direction. So direction is also changed and also it is elongated. So here you can see the direction of the vector x has changed when a matrices A hits the vector x. So in this case, what will happen? Like the direction of the vector changes? Yes, correct. Option B, the magnitude is scaled. Yes, magnitude is also scaled. So both the options are correct. But if we multiply vector x with eigenvector, then what will happen? In that case, the direction will not change. Okay. So any doubt in this question? So after that we can move on to the next part. Like here you can see this A is the eigenvector. So when multiplied with AX, it is giving in terms of lambda x. Okay. So AX is equal to lambda x. Here lambda is the eigenvalue. A is the eigenvector corresponding to that eigenvalue. Okay. What is A? A is the eigenvector corresponding to lambda corresponding to the given eigenvalue. Okay. So if you have any doubt, then you can ask in the chat box. Else we will move on to the next question. And also, like if you have not attended the week fifth lecture, then you can go watch it. And after that, if you watch this tutorial session, it will be more beneficial. So now coming to the next part, that is dominant eigenvalue. Okay. So we will see what is dominant eigenvalue. Like the eigenvalue, the like let's suppose there is lots. Let's suppose three eigenvalue. A matrix is having three eigenvalue. Lambda 1, comma lambda 2, comma lambda 3. So dominant and eigenvalue will be maximum among all the eigenvalue. Okay. Dominant eigenvalue is equal to maximum of all the eigenvalue. Let's suppose n eigenvalues are there for a matrix S. So the dominant eigenvalue is equal to maximum of all. Okay. So let's see one concept, because in the next question depends on this only. Let's suppose at the time step P, we are doing like x naught, a squared x naught. So at AP x naught, it becomes k into ED. Okay. So here you can see when we multiply like with A again, that is AP plus 1, that we can write. This you must have studied in the lecture. AP plus 1, A to the power P plus 1 into x naught. What we will get here? We can multiply A in this. So it will become, this term is k into ed. So we will take k this side and a this side. We have reversed. So we will get k a into ed. Okay. And what is a into ed? That is lambda d into ed. Understood? Because we know that ax is equal to lambda x. Okay. So a is the eigenvector here. A is the lambda is the eigenvalue here. So this lambda d is the eigenvalue. So ax is equal to lambda x. Okay. So here AD we can write it as lambda d ED. Now again we, let's suppose, increase the power of A, like at the time stamp P plus 2. It will become A P plus 2. That we can write. We'll multiply here A. So we'll got A to the power P plus 2. Okay. And now our this term is this K lambda D into ED. So K lambda D AED, again AED is equal to how much? Lambda D into ED. So this will become like K lambda D into AED is again lambda D into ED. So that will be is equal to K lambda D square ED. So general term, how we can write A at the time stamp P plus N, that is A to the power P plus N into x naught, that is equal to lambda D to the power N. Here you can see when power is P plus 2, that is lambda D squared. So we can write in this way. Now our this right hand side depends on the lambda d to the power n. So let's suppose if lambda d is less than 1, then what will happen? Something less than 1 to the power, higher power, it will like vanish. So when lambda d is less than 1, it will vanish. When lambda d is greater than 1, then this term will explode. Okay, like let's suppose 1.2 to the power something like very huge power, infinite, it will go to infinite. So in this way, if lambda d is greater than 1, then it will explode. And when lambda d is equal to 1, it will reach a steady state. Okay. So lambda, what is lambda d here? That is the dominant eigenvalue. So this term is controlled by dominant eigenvalue. Understood? So now we'll solve our next question. If you have any doubt in this concept, then you can ask. So, okay, so we will move on to the next question that is based on the dominant eigenvalue. Consider the dominant eigenvalue of matrix A is lambda d. What happens to the sequence x naught, ax naught, a squared x naught when lambda d is less than 1? So what will be the answer? Like we have already seen that this term a to the power p plus n x naught, what it will be? It will be lambda, it will depend on the lambda d to the power n. Okay, and here it will be ed and some constant k. So now you can see it is depending on lambda d to the power n, and lambda d is less than 1, and this is like this series is going up to infinite dot dot dot. So something less than 1 to the power infinite, it will vanish. It will become 0. So which option is correct? It will vanish. Option B is correct. Any doubt in this question? I have seen something in the chat box. No. For this question, it will vanish because lambda d is less than 1. If lambda d is like greater than 1, then it will explode. Here you can see the three case. And in a stochastic matrix, the lambda d is 1. We know that in a stochastic matrix, the dominant eigenvalue is equal to 1. So always it will reach a steady state. And what is stochastic matrix? Like either the sum of all the row, like sum of all the element in a row or in a column is equal to 1. Okay, so now we'll move on to the next question. Which of the following is true for dominant eigenvalue? Magnitude of this eigenvector of a matrix is greater than any other eigenvector. For any stochastic matrix, the dominant eigenvalue is 1. So just reply the answer for this. Just now I have discussed this concept. So like the first statement you see, the magnitude of this eigenvector means the eigenvector corresponding to this dominant eigenvalue is greater than any other eigenvector. That is correct because the magnitude of eigenvector corresponding to the dominant eigenvalue is greater than any other eigenvector. Now option B, that is for any stochastic matrix. Option B, for any stochastic matrix, the dominant eigenvalue is 1. So this is also correct. For a stochastic matrix, the dominant eigenvalue is 1. Means the highest value of lambda, that is the highest value of eigenvalue will be 1 for a stochastic matrix. So both options are correct. So option C is correct. That is both. Yeah, Abdul. Stochastic matrix are those matrix whose sum of all the sum of all the element in a row is equal to 1. Either sum of all the element in a column is equal to 1. Like let's suppose this is a stochastic matrix. You can see the sum of all the column here is equal to 1. Sum of all the element in a column is equal to 1. And here also you can see it is equal to 1. So this is stochastic matrix. Either of the way it is true. Or this is also a stochastic matrix. If sum of all the element in a row is equal to 1, then also it is known as stochastic matrix. For such kind of matrix, lambda d is equal to, that is the dominant eigenvalue, that is equal to 1. Okay. So now coming to the next question, that is based on dimension reduction. So given a set of 100 dimension in a data set, identify the condition to select a subset of fewer dimension to represent a data. Like how do we reduce the dimension? Let's suppose these are the points in a data sets. Okay, these black points are the points in the data set. So when you see, yeah, it is correct. Dimensions should be linearly independent. So when you see here, with respect to x and y, this this data points are well varying, like depending on x and y. But what if we take our basis vector in this way? Just wait. Let's suppose we changed our basis vector. So in this way, what will happen now? Now you can see it only depends on u1, because there is a slight change in the direction of u2, that you can consider it as a noise. So we can here remove u2 to reduce the dimension. Like two dimension, this data set which was depending on x and y earlier. So first we have changed the basis vector. So now this is u1 and u2, two different dimension. There is a like now this data set is depending only on the u1, because there is slight change in the direction of u2, that you can consider it as a noise. So now we can reduce the two dimension to one dimension. Okay, but the u1 and u2 should be linearly independent. Okay, so here the dimension should be linearly independent. So any doubt in this question? No doubt, then we can move on to the next question. Okay, so now coming to the correlation, consider the set of features in a sportsman data sets, that is name, age, contact number, city, weight in kg, height in centimeter, height in inches, and identify the attributes that are highly correlated. Option B. No, it is asking the attributes that are highly correlated. Like age and height, these are not correlated. Some people have some people have same age but have different height. Okay, and also it does not depends. Height does not depends on age, so that is not correlated. Again, height in centimeter and weight in kg. So again, the height and weight, yeah, option C is correct. So again, height in centimeter, like even height and weight, both are independent. Some people have same height but different weights, and it is not correlated. So it is independent. Now you can see height in centimeter and height in inch. So it is correlated. Like we can transform, like let's suppose there are 5% in our data set, that is P1, P2, P3, P4. Okay. And height in centimeter is given 10 centimeter, not 10 centimeter, 100, 110, 120, 130. Let's suppose four kids are there. So height in inch will be just the multiply, like I will see. I think 0.29, I think, inch to centimeter. It is 0.39. 1 centimeter is equal to 0.39 inch. Okay. So this will be equal to 39 inch. So in this way, just it will be a multiplication. 1 centimeter is equal to 0.39 inch. So it will be centimeter, like whatever the height, into 0.39. So these two features are correlated. So we can easily remove one of the features from our data set because it is redundant and it is just taking an extra space. So option C is correct. So if you have any doubt, then you can ask. We'll move on to the next question. That is based on the eigenvector. So which of the following statements hold true for eigenvectors? Eigenvectors of a squared matrix are orthogonals. So is this correct? Yes, this is correct. Eigenvectors form a convenient basis. Yes, because all the eigenvectors are independent. So it form a basis. So we can represent any vector using the eigen vector in the same dimension. Eigenvector of any matrix A that belongs to Rn cross n having distinct values are linearly independent. Yes, if all the eigenvectors are having distinct value, then that is linearly independent. So all of the above is the correct option for this question. So I will see the chat box. Yeah, option D is correct. Now coming to the eighth question. The eigenvalues for a n cross n matrix is given as 11, 3, 32, minus 3, 4. What is the dominant eigenvalue? So we have already discussed previously. Dominant eigenvalue is the eigenvalue which is having the highest value among the all. So like let's suppose there are n eigenvalues. So dominant eigenvalue, that is equal to lambda d is equal to maximum of lambda 1, lambda 2, lambda n. So here it is 32 is the maximum. So option C is correct. Yeah. Now coming to the basis, that check if the given vectors form a basis for R3. Before that, we will see some concepts also. Like this means that in the three dimension, all these three vector can transform, can used to define any vector, then it is called as a basis. Okay. So it should be linearly independent. So what is the definition of linearly independent? A set of vectors are said to be linearly independent when, like here, a1 x1 plus a2 x2 plus plus an xn is equal to 0 only for all ai is 0. Okay. So this is the definition of linearly independence. A set of vectors x1, x2, x3, xn are linearly independent when a1 x1 plus a2 x2 an xn is equal to 0 only for all ai is equal to 0. Okay. So now in this question it is asking check if the given vectors form a basis for R3. So we can find in one more way, that you just take all this vector in a matrix, that is 1 1 0 2 3 0 1 2 3. Now we have to check whether one of them are dependent on other two or not. So if it is not equal to 0, this means it is independent of each other. Okay. So just calculate the determinant. So it will be 3, 3 into 3 minus 2. So that is equal to 3. Just I am taking from the last row. So our answer will be 3, not answer. So it is non-zero. So determinant of A is non-zero. This means this can span all the vector in the dimension R3. Okay. So this is the basis in R3. These three vectors are basis in R3. Also, what you can do, you can find the rank of this A. If rank of A is equal to n, that is like how many vectors are there, then also these vectors will form a basis. Okay, understood? Any doubt in this question? Now coming to very simple theoretical question. Yeah, option A. Yeah, correct. Principal component analysis. How does PCA reduce the dimension of the large data set? So we'll see. At first, what we do, we just change the basis that should be linearly independent, like what we have seen in this example. We have changed into U1, U2, that is linearly independent, and we are reducing uh, U2 here. We are converting it into one dimension. We are reducing it into one dimension. Why? Because in U2 there is very less variance. Means whatever is change, you can see in U2 direction the data is not varying. Just there is little changes, that is due to the noise. That you can say that it is very having a very less variance. So we can reduce the dimension having in that direction if the variance is low. So we can write. So you can see the option C is correct. The direction along which the variance is minimum is discarded. Okay. So option C is correct. Also, let's see the option A. PC exploits this fact by representing the data using a new basis compri- comprising only the top k eigenvector. What is top k eigenvector? That is depending on the k eigenvalues, or even one eigenvalue can have multiple eigenvectors. So depending on the significant eigenvalue, whatever are the top k eigenvectors, that only we will choose. Remaining insignificant eigenvectors, we will ignore it because it will not contribute much in the creating the data points. So option A is also correct because we represent the data using a new basis. First we have to convert, like earlier it was xy. So we have converted into u1, u2, and after that we have ignored u2 because in the u2 direction the variance is minimum. Now see the option B. The n minus k dimension which contribute very little to the reconstruction error are discarded. So this is also similar to the option C only, because the n minus k dimension which contribute very little to the like the error is very minimum in that are discarded. So like we have discarded U2. So all A, B, C are correct. So option D is the correct option. That is all of the above. Is anyone speaking anything? Your voice is very low, I guess. Okay, okay. So in this question, how does PCA reduce the dimension of the large data set? So whenever we have to reduce the dimension, first what we do, first step is like we represent the data by new basis. You represent the data by new basis, okay? And in that we can ignore those directions in which the variance is very low or error is very low, like which does not contribute any error in that direction. Like let's suppose we have given the example here. These black dots are our data points. So in XY direction, it is varying with respect to X and Y both. But when we change this into the basis of U1 and U2, you can see these data points are depending only on U1, because whatever in the U2 direction is just a significant noise only. Like this data is linearly in the direction of U1. This is very low value, like direct in the direction U2, the data points is not varying much. So the variance in the U2 is very low, and also it contributes very less error in the direction of U2. So we can here ignore the dimension U2. We can directly change the two dimension data in one dimension. But always remember, we cannot ignore in X and Y that we can ignore Y. First, we have to convert in the U1 and U2 basis, then you have to ignore U2, because now all the data points are depending on U1. So option B and option C, the explanation of option B and C I have told you now. And option A is that PCA exploits this fact by representing the data using a new basis comprising only the top k eigenvectors. So this top k eigenvectors depending on the uh, like dominant eigenvalues, like not the most dominant. There will be many dominant eigenvalues. Some eigenvalues which will contribute very eigenvector with very low magnitude, that can be ignored. Okay, clear? So all of the above option is correct for this question. So option D is correct. Okay, thank you. So now we will move on. Yeah. Yes, yes, it is shared. It will be uploaded on YouTube, and when you go to the NPTEL portal, there you can see the uh, tutorial session link is there. When you click, you will go to an Excel sheet. In that, you will find my name in TA3. So in week 5, TA3, you click the link, you will get the YouTube video. So it is uploaded, the link is uploaded on NPTEL portal of this course. You can find it. So now coming to this question, like rank of a matrix. The number of we also know what is rank. That is the number of non-zero rows in a echelon form of a matrix. Why do we need to calculate rank? To know that how many eigenvalues are there for this given matrix. Okay. So the number of eigenvalues is always less than or equal to the rank of a matrix. So here this matrix is given. So we can use the row echelon form. Like we can use the elementary transformation, that is row transformation or column transformation, you must be knowing. And we can convert this matrix into row echelon form. And after that, we can find the rank, like the number of non-zero rows in the row echelon form is the rank of a matrix. So I think this is the last question. So let's solve it. And also, if rank of a matrix is like this is 4 cross 4 matrix, if rank is 4, that is the maximum of rows or column, then all the rows and columns are independent of that matrix. So that can form a basis. So rank is one of the most important parameter of any matrices. So let's see here. We have to first convert it into row echelon form. So what we will do, we'll try to make these two elements as 0. So we can do R2. This is R2 is will transform into R2, 2 into R2 plus R1. So 2 into 2 minus 2 will be 0. Okay. And same we can do R3 is 2 into R3 plus R1. So after this step, we will get minus 2 minus 1 minus 3 minus 1, 2 minus 2 0, 4 minus 1 3, 6 minus 3 3. This is minus 2 minus 1, that is minus 3. Now 2R3 plus R1. So this will become again 0 minus 1, 2 minus 3 minus 1. This is 2 minus 1, that is 1. And this R4 will remain unchanged. Okay? Any comment? Option B, let's see. Even I don't know what is the rank of this. Let me calculate. So now what we will do, we will try to make these two elements as 0. So now we will do R3 tends to 3 into R3 plus R2, and R4 tends to 3 into R4 minus R2. Okay? Because minus 3 plus 3 is 0 and 3 minus 3 is 0. Yes, correct. So let's do now. After this, what we will get? This row will be remain unchanged, minus 3 minus 1. This is also unchanged. This is 3R3 plus R2. Okay, 0. Minus 3 plus 3 0. Minus 3 plus 3 is 0. 3 minus 3 is 0. This will be 0. 3 minus 3 is 0. Again, 3 minus 3 is 0. Minus 3 plus 3 is 0. So now you can see in the row echelon form, this is the row echelon form. So there are two non-zero rows. Okay. What is the definition? The number of non-zero rows in the row echelon form of a matrix is the rank of matrix. So here rank is 2. Okay. So there is 2 independent vector in this matrix. Okay. This means. So any doubt? This is just a basic way. If no doubt, then I think we have discussed all the questions.
The starting element is 0, no?
In which?
In the final matrix, in the second row, the first element, that is 2, comma 1, is 0.
2, comma 1. In the second row, this row you are saying?
First element is 0.
Yes.
But by definition, in row echelon form, 2 non-zero rows you are saying.
So non-zero rows means like if any of the element in a row is non-zero, like let's suppose this is also a non-zero row. Like this is 1 is there.
Okay.
0 rows means all the elements will be 0.
Okay. Fine, sir. Fine. Thank you.
So for today's we have done. So we'll close the lecture here. So you can find the video, like also we will upload this on YouTube. So you will get it on the spreadsheet in the NPTEL portal. There you can find this all the solve means this all the tutorial session which is taught by different TAs also. So thank you everyone. Thank you so much. So we'll meet in the next week, that is week 6 on Saturday. Thank you.